Hi and welcome to my channel. Today we are answering an important question. So why do we even need clustering in the first place? And how does Checkpoint ClusterXL provide a solution? So in every secure network, the security gateway is the gatekeeper. It is your digital bouncer, inspecting, filtering and protecting your data from threats. But there is one major risk with having only one gateway. So as we can see here in this depiction, we have the internet and we have only one gateway. So what happens when it fails? So what happens when this gateway fails? A software crash, hardware issue, or even a simple misconfiguration, and suddenly your entire network becomes vulnerable. VPNs drop, remote access fails, business stops. This kind of downtime is unacceptable, especially in environments where availability, security, and continuity are non-negotiable. And that's exactly why gateway clustering exists. And that is to ensure you are never relying on just one lifeline. When uptime is critical, a single gateway isn't enough. That's where Checkpoint's ClusterXL comes in. A robust built-in software solution designed to eliminate single points of failure. And let's underline a software solution, so you don't need to buy any more devices. So ClusterXL is not a separate product, as we said. It is included as part of your Checkpoint security gateway installation. It works by grouping identical Checkpoint gateways into what we call a security cluster. And the result, your network becomes resilient. If one gateway fails, the other takes over without any manual intervention. And in most cases, without dropping a single connection. ClusterXL provides two core functionalities: high availability to ensure continuity during failure, and load sharing to distribute traffic for improved performance and reliability. So let's show this image here. So here we can see this topology. We have two different gateways. One is active and one is standby. So this is the high availability cluster. So in high availability, only one gateway is active, as we can see here. So this one is active and this one is standby. The rest are on standby. So this one is on standby, constantly syncing state information to take over in milliseconds if needed. So we have sync interfaces between these two gateways. This means your users keep working, your tunnels stay up, and no one even notices the switch. In load sharing mode, all members are active. Traffic is divided among them. If one fails, the others pick up the load seamlessly. This combination not only protects against failure, but also boosts overall throughput and makes upgrades or maintenance far less disruptive. So if let's say that this gateway fails, so this gateway is connected to this switch and to all other servers. This fails, this one will take over. This is still connected to this switch and to all other servers. So it is about zero disruption. So ClusterXL makes your gateway stronger, faster and smarter without the need for additional hardware or software. Now you might wonder, how does this actually work under the hood? So here, as we said, we have this sync interfaces between these two gateways. The ClusterXL uses something called state synchronization. And state synchronization is the process where all cluster members, firewalls in this case, constantly share up-to-date connection information with each other over a dedicated sync network, which is this network. So I got this topology here. You can see we have this network, the 10.1.1.1 or the 10.1.1.0 network, which is dedicated for the sync process. This ensures that if one member fails, another can instantly take over the traffic without dropping ongoing connections. Each firewall keeps track of the current session states, like OpenTCP sessions, and syncs that info with peers. This is crucial for zero downtime failover in a cluster setup. It happens over a sync interface, as we said here, these two interfaces. This allows every member to be aware of all active connections, so failover is seamless. And the outside world, the cluster looks like one device. So if we back here, so we can see that the active has its own IP address, this one. The standby has its own IP address, but the internet sees only one IP address. So let's look at our cluster here. If we double click, here we can see this is our virtual IP address. So we have this gateway here active, but the outer world will only see this. So if this one fails, this will take over, but the virtual IP is still the same. So this IP will answer all the time. So let's test login. So let's SSH admin. This one 8082. Let's log in. So we can use the command show cluster state to show the cluster state. So we can see that the 10.1.1.1 is active. So back there. So 10.1.1.1 is active, and this gateway is active, and this one is standby. This one is standby. Let's run a ping. See, ping. Let's ping the virtual IP address, which is this one, and let's do failover. So set cluster. So local is active, member down, admin down, something like that. And you can see here we have lost only one ping. And now if we run that command again, show cluster state, and we can bring it up. So down, make it up, and now we have changed place. So this video is done here. So this was a very introduction to the cluster process. So we will make some videos about this principle. So thank you for watching, and see you in the next video.